Assalamu alaikum, dear students. How are you? I hope you are all fine and doing quite well. Now you are in semester 5th and you have studied different branches of physics while you were studying in FSC. You have read about their names as mechanics, waves and oscillations, heat and thermodynamics, and many other branches. One of which is classical mechanics. Now we have to start our new subject and new course, that is classical mechanics. So now I welcome you all in the online course for the classical mechanics. Today is our very first lecture. In this lecture we will take introduction of classical mechanics, and with it we will take a brief review of Newtonian mechanics. You have read about the Newtonian mechanics before in your previous classes, in matriculation and in your FSC intermediate, that the laws which were described by Newton are followed in Newtonian mechanics. So the in classical mechanics, Newtonian mechanics is obeyed. Now students, I will tell you about the classical mechanics. As you have read about that science is evolved in a very long time. So we can say that classical mechanics is the oldest branch of the physics, or if I must say, it will not be wrong that it is the most fundamental and old branch of physics in all sciences, and that is class mechanics or classical mechanics. Students, you have read about or heard about mechanics. There must arise a question in your mind that what is mechanics? In mechanics, we study how the objects move, we study the motion of the object. Here we should keep in mind that in mechanics, we do not study why objects move, but in mechanics we study how the objects are moved. I hope you have understood that easily. Now we will discuss further. Here are some contents for the chapter we are going to start for our course. First of all, we have to discuss about the definition for mechanics and understand the terminologies for the mechanics, that how mechanics evolved and from where its concept appeared. Afterwards we will discuss about the classical mechanics, how, as previously I told you about, that it is a very old branch of physics. In classical mechanics, afterwards we will discuss what is Newtonian mechanics. Then the terminologies used in mechanics will be discussed. Some of the definitions for the mass, inertial mass, gravitational mass will be discussed here, that have the relation with the force. So we will discuss about the definition of the force. Further, the force has the relation with the motion, means that if there is any external force present, then the object will move, and without any external force the object cannot move. Then in classical mechanics we will discuss about what is space, and we will find the relation of force with displacement, velocity, and acceleration which have the effect with each other. Then we will discuss about the particles and system of particles. Afterwards, we will discuss about Newton's law, in which we will discuss about Newton's first law, and then we will discuss about the inertia. At the end of the lecture, there are some references of the books from where you can have the guidance. Now, we will start about from the history of classical mechanics or mechanics. So, we have to discuss that in mechanics, the parameters which are involved, students, that are force, mass, and acceleration. As I have mentioned here, these are the basic parameters which are to be discussed in the course, of whom we will take in the entire course. In start, I have already told you that mechanics does not discuss all the objects, does not discuss all about why objects move, but what is important for us, that how objects move, and force and the other factors, how do they affect the motion. That is the previous discussion I have told you in the start of the lecture. Further, here you can see the definition for the mechanics, that the branch of physics that describes the motion of the condition of the rest or motion of the material around us under the action of forces. Means that I have told before that if there is external force present, then the object is called to be in motion. So it means the rest or the motion condition of the object is described by the action of forces on it, external forces. That is called, that branch of physics that describes the condition of the body, that is called mechanics. So we can say that deals with the mechanics deals with the rigid bodies, elastic bodies, and fluids. For this, we will see the brief history of mechanics, that from where mechanics originated and start started, who played the role of development in mechanics. But before that, the two major branches of physics will be discussed here. In mechanics, students, we study motion, but for motion, mechanics has two more branches that are described under the mechanics. The first one is kinematics and the other one is dynamics, that you have read about as a chapter in your first year. Here, first of all, students, in the two branches, we will discuss the motion, but first of all, in kinematics, we will study without discussing the force and the mass. Means that in kinematics, we will see that what is the relation between velocity with the acceleration, distance, displacement, acceleration, and their interrelation with each other with all the other quantities. In kinematics, we do not study about the cause of the motion. We only discuss how do they affect on each other, how they interchange. That all things we shall discuss in kinematics, but in dynamics we will in dynamics in kinematics we will not discuss about force and mass, as I have told you before. Here, in second branch of which is dynamics, we will discuss about the mass and force. We will explain about force and mass and their effect of motion on the objects, that what is the role of mass, what is the role of inertia, what is the role of inertia in it, that all will be described in dynamics. So students, that was the some basic definition we have done for mechanics. After that, we will discuss about the history of classical mechanics, which can be discussed here. Before discussing about the subfields of classical mechanics, that are relativistic mechanics, quantum mechanics, statistical mechanics, and quantum field theory that deals with the different states of motion, we will discuss about the history of mechanics. The history of mechanics is got from Aristotle. It started from his era. Very before of him, people do had knowledge about and knowledge and discussion about the motion. There are many references found on it in the history. So, the very first name in this history of motion is Aristotle. Aristotle believed that for the motion of any object, force is very necessary. It means an external force is quite important for the motion of an object. We always need an external force. So students, we are going to discuss about brief history of mechanics. In this we have got the first name of Aristotle. As he had said that we need force for any kind of motion. Afterwards of Aristotle, there was a long gap or a break for the development of mechanics. There was not any kind of big breakthrough in the advancement of mechanics. The development was not as much uh, for the major break or development seen or advancement seen in the mechanics that may can make a huge impact in the history. The greater development was done in 17th century. In 17th century, there were two greater names that came into sight. The first name was of Galileo and second was of Newton. In first place, Galileo gave some fundamental rules that when objects move, they obey certain types of rule, and with it Galileo gave the concept of inertia, that what is inertia. So with this concept and certain rules, the minor developments were done by Galileo. After Galileo, when he have given some rules, major development was done by Newton. So the second name of Newton is a very big break for the advancement of mechanics. Newton gave a very massive breakthrough in mechanics. He set some rules, and these rules were defined as before, which were given by Galileo. These rules were afterwards named as laws of Newton. So today, still we all we all call them Newton's law, or they are known as Newtonian mechanics. Newton's laws development in mechanics, mathematics, calculus are very important and have a key importance, means that they are very important and have a and are like a backbone for the development of these theories or these subjects. Newton's laws or Newtonian mechanics has no exception. In daily life, you can see the objects moving with the motion. You can see the objects moving. With that, you can see the motion of galaxies, motion of stars, rotational motion of Earth around the sun, and the other motion of all objects have the effect of Newtonian mechanics. The laws of physics are applicable on it. There are certain limitations to these laws, but they will be discussed further later on. Newton's laws are everywhere, from falling off an apple from the tree on the ground to the rotational motion of the earth around the sun, motion of the galaxies approaching closer to each other, galaxies moving apart from each other. In everyday life, everywhere you can see the mechanics and the and laws of motion that are given by Newton, and the Newton's law of gravitation are also seen everywhere in our daily life. So the all things are found in Newtonian mechanics as the Newtonian mechanics or Newton's laws applicable everywhere, and they are applied everywhere, but there are some limitations in it. We will discuss about few limitations here and how these limitations can come into play. For this, if we first talk about microatoms or micro world of atoms or smaller particles, subatomic particles like electron, photon, and neutrons or photons, at that level, students, the Newton's laws are not directly applicable. So here we have to replace quantum mechanics in rather place of classical mechanics. Means that in classical mechanics or Newtonian mechanics, we cannot apply all the laws directly, but in place we use quantum mechanics. Here is a question. Some people may say that classical mechanics may fail at subatomic level, but it is not actually true. It is said that at the subatomic level, you can say that quantum mechanics is the extension of classical mechanics. As in quantum mechanics, we develop a model of particles or we study the motion of particles, then our basic concepts are of classical mechanics are extended later on to become classical mechanics to quantum mechanics. We that we have to study subatomic world. Here is another thing or limitation. If we have to study the particles that are moving with the speed of light or nearly speed of light with 70, 50 or 30% of speed of light, then classical mechanics or quantum mechanics are not applicable. In this case, a new form of mechanics is used to study the mechanics, and that mechanics is called the relativity mechanics, in which the subatomic particles or the particles which are moving with the speed of light are studied. Now, we can say classical mechanics is one of the oldest branch, as I have discussed before, which have a major role in science, engineering, and technology. And I have told that is Newtonian mechanics. There are three kinds of formalisms that are discussed in classical mechanics, and we have to study in classical mechanics further in our subject. That is, first we are discussing about Newtonian mechanics. Afterwards, that is Lagrangian mechanics, and third one is Hamiltonian mechanics. We can say that classical mechanics describes the motion of macroscopic objects. As I have told you that if we are dealing with the subatomic particles, we cannot use the classical mechanics laws directly. It means that the motion of macroscopic objects is discussed in classical mechanics, such as projectiles, parts of machinery that are in motion, as well as astronomical objects such as galaxies, spacecraft, planets, stars that are discussed under the influence of classical mechanics. As I have told you here, that the objects moving with the speed of light cannot be studied under direct classical mechanics concepts. There is another branch of physics that is under mechanics is called relativistic mechanics. But for this, there are some rules or laws in classical mechanics that are universal, that are not need to be changed in any kind of modification at any stage. Even that is, if the particles are moving with the speed of light, that rules cannot be changed. In which the first of all is the law of conservation of energy, law of conservation of linear momentum, law of conservation of mass and angular momentum. These are all the universal laws that are as is it applicable in relativistic mechanics, quantum mechanics and classical mechanics. So students, these are the laws that need not any kind of modification in any stage. Here, that is the brief introduction and the history of classical mechanics we have discussed here. Afterwards, now we have to take brief review of Newtonian mechanics for a single particle. For this, we have to start with some of the basic concept of mass, inertial mass, as our course starts with the Newtonian mechanics with a single particle, Newtonian mechanics on a single particle or a point particle. For this, we shall discuss about mass. We have studied about the mass, that mass is the intrinsic property of the body which comes with the existence of a body. Means mass is a quantitative property of an object. Every materialistic object have a mass. You can say any body that is in existence in our world that has a mass. So we can fairly write as mass of a body is the characteristic that relates a force on a body to the resulting acceleration. We can say here that is said that if there is a body with a mass, then this mass of body relates to a force and the acceleration of body for the motion. Further, we will discuss about the inertial mass. The inertial mass is the property or the qualitative property of the mass, which was first described by Galileo, as I have told you before, that the concept of inertia was given by Galileo, who have first gave the laws of or rules of the motion of the object. That is said that no any object can move without force. As I have told you that quantitative measure of inertia of a body is called mass. So the mass is the measure of an object's resistance to the acceleration when the force is applied. It means that greater the mass, there will be greater resistance to the acceleration for the when the net force is applied on it, and there will be smaller resistance to the acceleration when smaller net force is applied. There is another property that is called the inertial mass, which was a concept given by Galileo. The mass that determines the acceleration of body under the action of a given force is called inertial mass. When an object moves under the influence of a acceleration, here you can see that we have a mass m and an external force F is applied on the left hand side, and this force provides an acceleration a. As the object is made of number of particles of mass m, then the resultant force is the sum of forces that is being applied on the object for the motion of whole object in the right direction. That is called the inertial mass. Further, there is a relation between mass and inertial mass with the force and its motion. Uh, Now, before we have discussed about the inertial mass and the inertial mass, after inertial mass, we have to discuss about the gravitational mass, and gravitational mass is associated with your gravitational pull that is applied by gravity. So the mass that determines the acceleration of the body under the action of the gravitational force, as you can see in the picture, that a man having the weight of mass with the mass of 50 kg, and the normal force applied by the force is 500 Newton, that determines the gravitational mass of the object. These experiments of Galileo and Newton has shown that mass of inertia and gravitational mass are equivalent. These can be understood by some of the examples, as when you can see or observe that when Galileo has given his law that when the balls are thrown from the very height of a tower, they fall with the same speed on the ground. Why is that so? It means if an object is of greater mass and a ball with a mass of smaller mass are thrown from the same height, but they reach the ground with the same time, within the same time, and hit the ground, it can be said as force is directly proportional to mass. It means that how much that the mass required, the force is provided by the gravity is same as the smaller mass uh, which is provided by the force, but the both balls fall on the ground with the same within the same time. And if we see that the weight is determined by W is equal to mg, it means that the mass is when applied by the gravitational force provided on the object which is on the surface of the earth, there is equal and opposite force, that is the normal force applied by the gravity, that is called the gravitational mass of the object. So the inertial mass and the gravitational mass are called the principle of equivalence. Further, in next slides I have some examples for your understanding for the difference between inertial and gravitational mass and how they are equivalent, and that they are set for the determination for the principle of equivalence between the gravitational mass and the inertial mass. If there is a apple of mass m and the gravitational force is applied on it, then the mass is given by m is equal to w by g. If we put an object in a gravitational field, it responds with its gravitational mass, that is called gravitational mass. And if similar mass of means apple of mass m is applied by an acceleration a, then it responds with that push with the inertial mass, that is given by m is equal to f over a. We can say that acceleration and gravitational acceleration are equivalent. So we can say that these two masses are same, which are described previous in the examples of principle of equivalence. The experiments have shown that the two masses are same in different conditions when the different experiments are done to prove that for the proof of the gravitational mass and the inertial mass. Now, for the Newtonian mechanics, as we have said that classical mechanics works under the Newton law of mechanics. For the first law of motion, which is given by Newton, the first definition is given for the force, which was first determined by Galileo. He said that every motion requires an external force, so it means that we should have a qualitative definition of the force. We can say that A force is something that changes or tends to change the state of rest or uniform motion of an object in a straight line that I have discussed or told you about earlier. Here is an example of an object. You can see a door, or you can say it is a cabin. On the left hand side, a kid is pulling that object, and on the right hand side, the other kid is pushing that object. Both the kids are applying forces on their relative act. One is pulling and one is pushing, and both of them are providing the force for the motion of the object. It means that if we have to tend an object from first one place to another place, we have to apply some force. If there is no external force present, then there will be no way of moving an object from one place to another. So in first law of motion, which is also called the law of inertia, we have now stated the definition for the force. It means the rest motion and the uniform constant motion are relative to each other. They have to be provided on the same time. Without that, the object cannot move. Here are some examples on the right hand side, on the left hand side. You can see on left hand side on the first picture that a child is sitting in a cart, and according to the mass, the force applied to the object should be equal to the mass. So a single kid cannot put a force for the motion of the object. So the force should be proportional to the mass is applied on the object for the motion. In similar way, you can see in the below picture that there is a mother that is pulling the cart, that is providing the equivalent force that is proportional to the mass of the cart, that is easy for the object to be moved. So for the motion of the object, we can say that the force and the mass should be proportional so that the object can be moved easily. On the right hand side, there are few examples that there is a door and a person is pushing it, but that is not the required amount of force with the mass that is able to provide to the object to move it from one place to another. That means that they are not proportional to each other. Similarly, you can see an example of tree. The apple is falling from the tree, and it means that the gravitational acceleration has provided the force for the object to fall on the ground. And one picture you can see of an cricketer that is hitting a ball which came from one side, and by force he has changed his direction of ball on the other hand side. There is another example of balloon that they are in motion. If there is no They will move in constant motion if there is no force applied on them to stop from their relative motion in the sky. These are the examples that describe that the force is necessary for the motion of an object. That motion can be of the two forms, that can be of rest state and that can be of uniform motion in one direction. That is, we have to discuss. Here is another definition we have to discuss in further study of the course, that is space. We have discussed or studied about the simple definition of the space, that is the geometric region in which the study of the body is involved, or we can say that it is a continuous area or an expanse which is free, available, or occupied, that is called the space. or we can say the dimensions of height, depth and width within which all the things exist and move, that is called space. Or we can say a simple another definition, that it is a period of time that is available for the objects to move. For this, to describe the position of an object, there must be a reference point for the study of the object, and this point is called origin, and the measurements set from that origin for the object, that are called the coordinates. If the coordinates involve only mutually perpendicular directions, they are Cartesian coordinates, and if the coordinates involve angle or distance, that are called polar coordinate system. There are different kinds of coordinate systems. There are three kinds of coordinate system. The first is Cartesian coordinate system, the second is the polar coordinate system, and third is the spherical coordinate system. Coordinate systems are used to describe the position of an object in the space. A coordinate system is an artificial mathematical tool that we construct in order to describe the position of a real object. There are three kinds as discussed before, that are Cartesian, cylindrical and spherical, or you can say polar coordinate system. In mechanics, in applied mechanics, the three common coordinate systems are rectangular or Cartesian or rectangular, or spherical or cylindrical Cartesian coordinate systems. The aim of the present section to describe these coordinate systems and to derive the formula for the transformation of the vectors is done in the coordinate system with respect to the others, that is called the space. As I have discussed earlier, that mechanics is under the influence of two mechanics, and that is the kinematics and dynamics. And in classical mechanics we deal with the branch, that is kinematics, in which we study the object, how the objects move, but we do not study the cause of the motion. So the forces and masses are not influenced as much. In this we see the displacement, velocity, acceleration, and their interrelation with each other, and how they are influenced by each other. In this respect, for the first thing, that is displacement, the simple definition you have studied before as well, and you know that displacement is the vector quantity, and I have earlier told you that vectors are used uh, to describe the or find the resultant of the vectors in the Cartesian coordinate system or the other coordinate systems, that we need vectors. So the displacement is the vector quantity. So we can say that the distance moved by the body in the specified direction is called displacement, and the representation of the displacement is done by small d with the vector sign above it. Then we can say that d is equal to r2 vector minus r1 vector. R2 is the position vector in a coordinate system, and r1 is another vector in the coordinate system, and difference between the two vectors is called the displacement. So in a specific direction, when a body is moved from one point to another, it is called displacement, which is a vector quantity. That vector quantity requires a magnitude and a direction. It means that if I have to move 5 meter or 5 kilometer in each direction, within this I have specified my magnitude 5 kilometer and the direction east, which is specified for my motion, that is called displacement. If I only describe the direction or only describe the magnitude, that is not a complete description for the representation of the displacement or to describe the displacement. Now the first thing we have discussed here is the displacement, that is d is equal to r2 minus r1, the difference between the two vectors, which is a vector quantity, which arises after displacement. And I have told that displacement and velocity acceleration have relation or interrelation with each other. After displacement, the first definition is the velocity. So when the displacement changes with the time, or we can say the rate of change of displacement is called velocity. It means that if I have to move 5 kilometer in some specific direction east, then if the time is specified of 10 second or 1 minute or 60 second, it means that in that interval of time I have to cover the displacement at the equal rate divided into the time, and that will be called velocity. Here you can see v is equal to dr over dt. R is the position vector as described before. So velocity will also be the vector quantity. Here d over dt into r vector gives us r dot. The representation of the differential form of a position vector of the first order, we can use a first single dot above the vector with the vector sign. So we can say that v vector is equal to r dot vector, that is called velocity. In classical mechanics, we use the differential forms of the vector representing by the dots above it. For the velocity, it has a single dot on the position vector, that is called dr over dt. So we can say the velocity is also the vector quantity arising from the another vector quantity, which is displacement, and which is divided in equal interval of time. After velocity, displacement, velocity and acceleration, as I have discussed earlier, there is another definition that is concerned in the classical mechanics, and that is the acceleration. As displacement is d is equal displacement is equal to r2 minus r1, difference between the two vectors, and velocity is the time rate of change of position vector r, represented by r dot. In similar way, the rate of change of velocity with respect to time is called acceleration. Here I can represent acceleration with sign A, and now the differential form will be dv over dt. If I put the value of v, velocity, that I have written before, dr over dt, then it becomes d square over dt square in the position vector form. We can say that here acceleration is in the form of position vector of the second differential order. Here now you see that dr over dt means velocity, and velocity with, if again differentiated, is given by v dot. So acceleration in the differential form of velocity can be written as v dot with the vector sign, and this vector with one dot of differential in the differential form of position vector r is represented by the double dot sign on the position vector r, that is written as a is equal to r double dot. Now we have three values of displacement, velocity and acceleration, which are to be used in the further classical mechanics course. We are discussing further and going on the other subjects, and Newtonian mechanics. You have to learn it, and you have not to forget it, because these terms are used further and further in the next steps and the other topics of the lecture on our course. Now, momentum. You have read earlier the linear momentum is p is equal to mv. So we can say that the product of mass and velocity of a body is called momentum. So we can write p is equal to mv. As you have written before that or read before that, v is equal to differential form of vector r and which is represented by r dot. So momentum is written as p is equal to mr. You know that momentum is a vector quantity and velocity is also a vector quantity. When multiplied by a scalar quantity m, it remains to be the vector quantity which is represented by r dot vector. The first definition further we have to discuss is the particle, and then afterwards we will discuss for a system of particles. A particle is an object which has only mass and no size. In dealing with the problems involving the distances considerably large compared to the size of the body may be treated as particles. If we have to solve some problems in which the distances are involving, then we have to consider the size of the object be considered as a particle. Examples of such situations are: if a ship is in a mid-sea, it is a particle to be studied by the relative motion of the control tower. Or we can say that particles are the bodies where all the mass is concentrated at a single point in the space. Particle analysis will only have to take into account the larger forces acting on the body and the translational motion, because rotation is not considered for the particles. In the study of movement of the earth in the celestial sphere, earth is treated as a particle. How matter It does not matter that how much bigger a particle is. For the study of the of the object in classical mechanics, the particles on the classical level are considered as particle. Now, as we are discussing for the Newtonian mechanics, in this will discuss about the Newtonian mechanics, the Newton's first law of motion. It states that when a body retains its state of motion unless an external force disturbs its state, it means that if the motion is in relative motion or it is in rest, it tends to state in the same condition as it is before, or either it is the rest motion or either it is the rotation, is the motion in a straight line. The word state of motion has two different possibilities. It may be rest, number one, or number two, motion. So, in other words, we can state that the law as a body remains at rest or in uniform motion unless acted upon by a force. I have told that you before. In this law, we see that the body is subjected to no force. So, the first law can be mathematically stated as: it means that when the object is at rest and no force is applied on it, we can say that mathematically all the sum of all the forces on the uh, body, that will be equal to 0. So a body is subjected to no force is called a free particle. So in classical mechanics, if there are the objects with no forces on it, it is called a free particle. And if there is a single particle acting on an object with the proportional to the mass, that is called the particle in classical mechanics. Here you can see a figure of mass m and a force F is being applied on an object. So the body has to accelerate with the acceleration A. It will keep its motion as it is if there is another external force to stop it. Another example you can see on the right hand side, that a man is standing in the upward direction on the ground, and a force is being applied by the object or a person in the downward direction, that is equal to the weight, which is W is equal to mg, which the object is in the stationary state. In the same way, the ground is providing the normal force upward in the direction of the weight, which is downward. The weight force and the normal force of the ground cancel each other, which states that the object or the person will remain in the position of the rest state. The object remains at the rest or in motion with a constant velocity when the vector sum of the forces acting on the object is 0. Therefore, an object that is at rest will remain at rest until or unless a force is exerted upon it. If there is a motion, it will tend to remain in motion if there is no external force like friction. and a person standing on a floor, if though there is no external push or pull, the person will remain in the state that is described here on the right hand side of the picture. As I have told you before, then if there is no force applied on the object and the object remains to stand in the same state, then the Newton's first law of motion is applicable only for the free particles. The object which with no force applied on it is a free particle, so then we can say that Newton's first law is applicable only on a free particle. The first law of motion introduces two important concepts. The first is the concept of inertia and the other is the concept of force. About inertia we have discussed earlier, and about force I have told you some definitions previously. Now, for the definition of inertia, a mass keeps moving once it is set in the motion. The property is called inertia. Same goes with the state of rest. If it tends to rest in the same state, that is inertia. That's why Newton's first law is also called the law of inertia, because he stated that the body will tend to remain in the same state if it was of the rest or if it was on of the motion. So it is also called the law of inertia. For this, there is an example of for the inertia. There is an example of Newton's first law of motion. You can see two objects on the right and left hand side. An object will not change its motion unless acted on by an unbalanced force which should be equal to the mass. It is at rest, it will stay at rest. Number two, if it is in motion, it will remain in motion with the same velocity. Objects with a greater mass have more inertia if it takes more force to change their motion on the left hand side. And the other example is Newton's first law of motion, which is the example of football. An object at rest will remain, and the object will be at rest if there is no external force applied by the other person. If an external person provides the force, the ball will continue in the constant motion and direction unless it is catched by the unbalanced force applied by the net. These are the examples that are easy to understand to get the concept of inertia. References for the study of classical mechanics. The first one is Goldstein. The author of Goldstein is H.P. Charlie and G.L. Sappho. 2001 Classical Mechanics edition, Weasley. Another is the Analytical Mechanics, that is the Cambridge edition. The another reference you can have is of Classical Dynamics of Particles and Systems by S.T. Thornton, J.B. Marian, and the fifth edition of Bayes Company 2012, John R. Tyler, Classical Mechanics 2005. These are the references which have to be followed. I have taught thoroughly about the first introduction of the object. Hopefully you have understood it. If there is any difficulty, you can ask me. Please give me your opinion that how I have explained the introduction of classical mechanics from the start. I know that there must be some questions regarding the topic. I am available to you for your questions to be answered thoroughly, and again with attention read your lecture and topic, which is from classical mechanics, and the classical mechanics concept is based on mechanics which we have discussed briefly in the lectures starting earlier. Thank you so much. As a whole the lecture I have taught completely. If there is any difficulty regarding any topic within the lecture, these are some YouTube links for your reference to understand your concept about the topic. Thank you. Hopefully you have learned a lot and follow the instructions and the topic clearly. If there is any question, you can ask me. In the next lecture, we will continue from the Newtonian mechanics and further impacts and effects on the motion. Thank you so much. Allah Hafiz.